Hello, folks. This is Willie, Laser to Leather, and we're going to do something other than leather. So, as I've mentioned in the forum and everything on Facebook, that I'm starting to work a little bit with silver, and today we are going to do this. It's name pendant. It is in sterling silver, 20 gauge metal. Uh, and we're going to do it from start to finish. Now, the video is long because it is from start to finish. Literally, we're going to design it in light burn and then take it over to the laser and do the full burn on it. I wanted to give you folks the true time frame, not speed anything up, not jump um, the processes or anything like that. That way, to where if you're thinking about doing it, you know exactly what's involved. Uh, so I'm not going to talk very long because it is a long video. So I hope you enjoy it. Again, this is Willie. Thank you very much. All right, folks. So what you see right here is the start of a name pendant. Um, we're going to walk through. I'm going to show you how I did this. It's pretty simple. One of the key things that you really need to look for, though, is a good font. Um, you're going to need a font with some meat on it. If it's got real thin lines, uh, you're going to have to do a lot of work on it. You'll notice on this one here, I actually created a weld coming across here and down here at the bottom. And this is just more or less me experimenting. Um, I'm not a pro at this, and I'm still learning the ins and outs of all of this. But I'm going to duplicate this here and show you where I made the mistake before. So obviously, you need to start with your text tool, and I have a font that's called Royal Signage. I really like it. Click out of there. Oops, sorry about that. And as you can see, it almost welds itself, but there's still a gap here between the N and the A, and then obviously your T is messed up too. What you can do, and the way I did it, is pick up your square tool and come in here and just draw a square and bring it across. Make sure that, and I made a mistake on my earlier one, but make sure that your square tool does overlap your across the top of your bars, because you want them to weld together and to take out that line. Uh, you can come in, and since it's already fairly welded, come in and drop it down just a little bit more, because you're going to have a good weld coming across here. And now, if you're working with gold, you might want it a little thicker, simply because gold's a little softer. But with silver, you can get away with it being a little thinner. Uh, we're going to select that. And then I just like to hit shift right off the bat, select your text, and then select your weld. Or actually, I do the bowling union of two shapes. You select there, and now you see it's running all the way across. And we're going to go ahead and do the same down here at the bottom. Select your square tool. Now, you don't necessarily have to do the square. There's a lot of options depending on your font and everything and how you work it. We're going to go ahead and draw our square tool across again. Don't try to get all super nice and neat right off the bat. Just get your square tool drawn out. Come over here, get your select tool, and then you can come in and kind of clean everything up and dress it in. This one here, you've got a fairly even line across there, so you can go ahead and keep as much as your letters as you can while making sure that you're staying on the inside of that line. That's going to make it to where it's going to weld across this line right here. And again, we'll bring this down in here. This isn't the prettiest method because what it's going to do is it's going to kind of leave this open here, but we'll go ahead and run it like that. And then once again, hit your shift and your other selection. Now, one important thing about using this tool right here is that you have to select, it only works for two objects, and you have to select your primary first and then select your secondary. And that kind of tells it, okay, this is what I want. You select there and see, once again, now that's all unioned across there. Now we need, very simply, our two circles. But before we get into that, we need to fix this spot right here. This is a weak joint right here when it starts to cut. You need this thicker. So we're going to go ahead, and once you've done this union right here, it changes this text out of a text to a, I don't know the proper word, but it makes it where you can edit the nodes into it, okay? So we're going to go ahead and ungroup. By the way, if you select that and there's none of these here, and you notice up here that it's grouped, when it's grouped, it will not work. So ungroup, and now we can come in here and we can adjust this line. And all we want to do is to make this right in here a little fatter, give it a little more meat, give it some strength, and we're just going to do a little bit of adjustment. And we can bring this in, and then you see this arm right here, you can bring that arm in, and that will smooth that curve in and give it a little more meat. So we worked here, so we'll go ahead and come over to this side. We'll do the same thing. Another trick too, if it starts getting away from you, is zoom in further in. The further you zoom in, the less or more precise the snap to grid's going to be. So you can come in a little tighter in your zoom, and that'll make it to where it's a little bit easier to work without it trying to get away from you. And you'll see here, this is a little uneven, so we'll go ahead and grab this, and we're going to pull it this way, and then gently bring it up. Really, a good idea in Lightburn is to get in there and play with these nodes. Once you kind of learn how these nodes work, you can do a lot with your artwork. Where I used to go to different photo editing and graphic editing software, I've started more and more actually using Lightburn and do all my work in Lightburn instead of jumping back and forth. And so utilize Lightburn. I mean, guys, the fact is you're paying for it, so make use of it. You'll find that it does have a lot of features. We can come in here, and again, notice that we got two arms here. And if we take this arm here and we bring it down, See how it smooths that curve in? We can go ahead and open this up a little bit more and then come over here and bring this in. Now, you'll notice this has extension. You can pull it out way up here, or you can bring it in. The closer it is into the object that you're working, the more, see how it's bringing that effect in. So just kind of play with your nodes a little bit. Nodes, not nose. Don't be rude. All right, we're going to bring this down here and open up that just a little bit more, make it a little fatter. Understanding how these nodes work and going in and editing these fonts is going to be very important in making a strong uh, name pendant that's not going to break on your customer or client. So you need to be able to come in here and do stuff like this. All right, we're going to bring this down, get this hump out of here. That looks really good. I like that. That's a little thicker in here, and that should open the fat up in here and give out a stronger joint right there. So let's get out of this node point, and now you can see it's still nice and smooth. It has nice lines to it. It's not getting all bumpy or anything like that. Now let's talk about our uh, joint, or our uh, uh, well, sorry folks, I'm not real good at this. Um, the rings for attaching the pendant for your chain. I like to stay somewhere around 3 millimeter and then go over and select your offset, and you can either go inward or outward. Um, we're going to bring this down just a little bit to 1. Select OK. And you can actually, so I've got this locked, so it's 3 by 3. And you can bring this down just a touch. Now you've got a good hole with a 3 or a 2 millimeter inside diameter hole. And you can come over and select this here. Down here. And we can adjust this down just a touch and center it up. And remember, we're actually going to weld this into this here. So it can be offset a little bit. It's up to you. Since we've got that selected, let's go ahead and draw your box across. I'm sure by now, if you've worked with light burn at any length of time, then you know if you go from right to left, then it's going to select anything that it's touching, like that. Or if you go from left to right, it will only select the whole object. So for example, my box is covering the inside circle, but only part of the outside circle. So now only the inside circle is selected because the box wasn't covering all of it. So it's a little trick you can use to kind of work in tight spaces. Now we're going to bring this in, and we're going to find a good weld point on this. Let's bring this right up into here. We don't want that inside circle touching, just the outside circle. And you can, set it up however you would like. I like to try to keep as much meat as possible in this because it is going to be a stress point. We'll go ahead and weld that. But first before I forget, we need to duplicate that and bring it over here. And we can just set it off over here to the side for now. And now we'll just bring this across from right to left and select it. And so it's selected both of these objects here, and we can weld it together with the weld shapes. And that closes that circle in. Now we'll come over to this side. We'll do the same with this. Bring it in, and we will work with the A and come into here, and then again, select there and weld in. And so you see, it's come in. We've got a decent weld here. And we could control Z out of that and deepen that weld by pulling this over here, selecting both these items, and bringing this in just a little bit deeper. Remember when I was telling you that if it's jumping around and getting out of control on you, zoom in deeper, and it gives you more precision. See the difference? So we're going to go ahead and go just a little bit deeper. And this will give me a larger weld point to this circle so that it's less chance of it breaking out. Now we can, by the way, if you don't have one, folks, I strongly suggest getting a trackball. It is it takes a little bit of getting used to if you're not used to it. But the nice thing about a trackball is it gives you a lot more control, precision, and you can work a lot faster. Now we can go ahead and select there, and look here. See how much deeper your weld is? This is going to be a much stronger joint than what was first selected. All right. So now it looks a little bit like an F instead of a T, but I think I can go with this. One of the other things that you need to do, and you'll notice over here I have two selections. And what I like to do is actually to select my outside circle, outside line, and it's going to stay in the black. And then I'm going to go with my inside here, and I'm going to change it to blue. Now, both of these are actually identical in power and settings, but the difference is that I'm going to make sure to move that blue up into the priority. And oops, what did I do wrong here? Oh, take that out of there. There we go. And I will come over here and deselect the output for the black. And I'll run these inside lines first. What that's going to do is it's going to take a lot of that excess travel out of the laser, and it will do all of this first, and then go and work on the outside line. Now, the outside line is probably going to be the hardest. And if you really wanted to, you could, because of the way I've done this, you could actually portion this out even further. So my laser is going to hit all of this in here first. And then I tell it to stop once I know that all this has been cut out and come over and start working the outside line. And that makes things much, much easier. I still notice here that this is going to be pretty thin. One of the things you got to keep in mind, folks, is that whenever you're working with silver or gold, you have to set your wobble. And when you work in that wobble, what you're doing is like you're taking one of those fat pencils that you got when you were in school and trying to draw a line with one of those fat pencils. Well, that means that that line that you're cutting out is going to be a lot fatter than what you're used to if you haven't used wobble before. So you're going to want to compensate for those fatter lines because it is going to take some of this meat off of this. So we're going to go ahead. I noticed, like I said, kind of noticed that I've got this one spot here. Let's go ahead and select that. Come over and touch up a little bit. Um, just bring this out a little bit more. And, well, you'll notice that, hey, it's going to be some touch up here. And I apologize for taking your time on the video. But I really wanted you, a lot of people cut all this stuff out. And the fact is, this is, when you're bidding a job, this is your primary time right here. Yeah, you got your leisure time. I'm not making a lot of that. But if you're doing things right, a lot of times, the majority of your time is going to be coming in and working on your customers' artwork or whatever you're creating. And it's been my experience that you're looking at somewhere between a 2-to-1 to 3-to-1 ratio in time working, doing just what I'm doing right now compared to the amount of time that actually goes on the laser itself. And I wish there was an easier way. There probably is to do this kind of stuff, but I don't know it. This is the only way that I know to do it. If somebody has a better way, by all means, let me know. Um, Again, I feel more comfortable working directly in light burn instead of jumping back and forth. That's a little better. And we got this spot right down here in this tail. Now I got a choice here. I can leave this or I can clean this edge up right here and just terminate it right here. And I think that's probably what's going to happen. So what we're going to do is we're going to go back to our select tool. Come over here. Nodes. And we're going to just start hitting the D key while I'm over a node. Now, if you do it on a line, you're going to delete the line. But if you hit the D key while you're on a node, you're going to take the node itself out. So zoom in here, hit that, hit that. We'll just keep working our nodes. In here, here, there we go. Now, see, I've cut all this down a little bit. Now you got a choice from here. If you look over here and you pull over here, you'll notice that it tells you. You see, C is convert node to corner. And so we can actually take this node and bring it out a little bit. Kind of round that corner off a little bit. And I have another one right here. And we can round this corner out here. Now, it ain't as fancy and pretty as the original one, but what that does is that takes this burr out right here in the bottom. And you got to remember when you're creating this jewelry that it's important to think about comfort. And sharp ends or sharp corners are not comfortable, especially when you start talking about pendants, which are going to be hanging around your neckline and into a woman's bosom. I mean, and gets caught up. That's not very comfortable. So when you're creating these things, you think about things like that. All right, I like this. I think this is going to do fine. We can go ahead and get it centered up. Whoops. See, Control Z. Let's go ahead and select everything, group it all back in together so we can work it. Hit P, get it back over in the center. And if you want to look at what it's going to look like, go ahead and hit the fill and fill. So our blue is going to be cutouts. This is the other reason why I like to select two different colors. One's for my cutouts and my main lettering. This gives me a visual representation much closer to what the pendant's going to look like. And it's always a good idea. So just kind of double check our work, make sure everything is welded like it's supposed to. Looks good. You can see here that, it's not going to be such a sharp edge. And I think it's going to look good, even if it is a fairly short name. It's going to be a little bit fat, but that's okay. It's fairly small, uh, 30, 31 in width. So I'm actually looking for something closer to 50 to 60. So we'll go ahead and hit that. Since it's locked in aspect, bring it up to 50. That brings it to 37. This is about 1.5 inches, which is just about perfect for the piece of uh, silver that I have worked. So let's see if you're going to have to pardon the camera for a second. I'm going to change the way these cameras look so that you can see my work area. All right, so I'm going to take you off a display and bring you into my workspace so you can kind of see what's going on here with the camera. All right, so make sure you're seeing what you're supposed to be seeing. Yeah, good. All right, so if you'll see here, this is the piece of silver that 2 hours ago, if you will, were a bunch of beads, silver beads. And what I've done is I have a uh, smelter and I melted it down. And then I have a rolling mill. And I milled it out. So whenever I first do this, it's just a little bitty square, about a 1/4 inch wide and less than about a 1/2 inch to a 3/4 inch long. And when I run it through the mill, it's about somewhere around, I'd say, a 1/4 inch thick, and it brings it down to a nice workable thickness. Some of the things that you're going to want to think about when you're doing that, when you're running it through the mill. Well, let me touch first on why I did that. Why a mill? You're going to have to pardon me because I'm a smoker and I'm going to smoke. So haters, do whatever you want. All right. So The reason why I ran this in a mill and the reason why I got a mill and a smelter, this stuff is expensive. I mean, when you start working with precious metals, you have to save everything that all your scrap. You can't just throw your scrap to the side. It's just way too expensive. Okay. There's only going to maybe be, at the most, probably about a quarter of this that will actually go into the pendant. And the rest of it's going to be scrap waste. Okay. So having my own smelter and my own mill makes it so that I can take that waste, go back into the pot, and bring another workable piece out of it. And it just saves money. It also makes it so that I can decide how thick of a pendant I want. Okay. This particular piece is, write this down, zero it out. This particular piece is about 0.80. It's a decent number. And if you look at the gauge for a 0.80, 0.80 millimeters to gauge. So a 0.83 is it's somewhere between a 21 and 20 gauge metal. Actually needs to be a little bit thicker. I would like it to be closer into the 1.5, which would bring it to a 16 gauge. But I'm still experimenting with this, and so I want to see where a comfortable thickness is while still being, not outrageously expensive to produce. You're going to need to also make sure to weigh it, because once you're done, then you have to calculate the amount of silver that went into the piece and then your amount of work that you put into it itself. So your silver plus your labor, and get your appropriate pricing from there. So the other part of this, and some of you folks have already gotten a clamp or whatever, but I'd actually gotten this part here on Amazon. I believe it was $40. And then I'm just using the hold downs that came with the laser as my arms. Uh, and interestingly enough, the screws also work in this tab. So it worked out really well. They're not perfect. I'm not going to make a claim that it is. But all I do is I run it underneath these arms. Be real careful here and try to get as much of the meat as you can while at the same time holding down. And of course, I set my heels off to the side here. Tighten it down. Once again, you want as much of the material as possible exposed, because it's going to need as much as you can get. Now, what I've done is I've clamped it in. So this way it's not going to warp as the heat hits it. And then once you've got it clamped in, pull that out, and that will help hold that tension outwards onto the piece itself. And this gives me a good point for my piece. And once I activate my laser, I can go ahead and cut that out. I could go ahead just real fast, folks. I'm going to change the subject because I've seen this happen too many times. Let's make sure that everybody understands the proper power up sequence on these lasers. Now, some of you, your buttons may be different depending on the type of laser you have. You'll notice that I've got my case open. That's because of a very, very fine gentleman named Pascal Liao, who sent me a a laser source upgrade. I bought it from him. Um, I cannot pronounce the name of the laser company he has over in China, or that he's part of. But if you are on Laser Everything, then you'll see his name come up a lot. He is definitely someone that you want to speak with if you're looking for an upgrade for your laser, or if you're wanting to buy a laser. But the proper procedure: first, turn on your emergency power or emergency stop power. Second, turn on your galvo and your board power. Third, very last thing, is turn on your fiber laser or your laser source power. Always, always, always. This is the very last button you turn on when you're powering up, and the first button that you power off when you're powering down. There's a very simple reason for this, folks. When you engage this switch, not only are you turning the galvo head on, but you're also turning the brains on. Okay, and that's the fact. You're turning the control board on. Okay, if your control board is not activated when you turn your power source on, then it can possibly pulse. Okay, just a slight, fast, quick bloop. All right. When it does that, if the galvo head is not powered on, then you have those two servo motors in there for the mirrors that might be lined crooked or not in line, not set at a 0 point, which means it might be shooting that beam out in any direction. So that is one of the reasons. Now, that's not the only reason, but it is a darn good reason to make sure to follow this procedure. The other factor is too that if this is turned on whenever you hit the power button, then you're running a pretty hard surge, 24 volts, in through all this system, and it's just not good on it. So, 1, 2, 3. Okay? All right. All right. I want to get you back over here. All right. Oh, one of the things, you're spending 3, 4, 5, 6, 8 grand for a laser system, and then you're trying to find the cheapest safety glasses you can find. Don't do that, guys. Get you some good glasses. Okay. Yes, they're going to be $100 investment, $150 investment, maybe even $200. Um, these here are some really good glasses. They're expensive. Um, I cannot remember where I got them, but I can tell you that I know that I spent $180 for them. I just can't risk my eyes. And these are really, they do real well. Um, I had bought these at a trade show and tested them also, by the way. These are not plastic, for one thing. That's glass. They're heavier, but they do have the proper shielding and everything on the lens themselves. And so not only do they work really well as far as the obvious safety feature, but they're a lot easier to see through. And if they're easier for you to see through, you're less likely to take them off when you're out here doing something. So go ahead and do your research, find a good set of safety glasses that you're willing to sit here and wear. Uh, Now, my problem is I also wear regular glasses, but usually when I'm working in this close of an area, I can take my regular glasses off and have my safety glasses on. So I turn this machine on, I put my glasses on. I ain't even started the machine, but when I turn it on, these go on. Start a habit. It's the same way you get in the car, you put your seatbelt on. It's a habit. Create that habit, you work that habit, you keep that habit, and it's less chance you're forgetting to do this. All right. So we got lined up. Let's go ahead and go over here. Make sure my power and everything is set correctly. So power wise, I have a 50-watt JPT laser source. I am running a speed at 100, a max power of 80, frequency of 40, which is the highest power for my system. Or what I should say is when I'm running the 40 frequency, that is placing the highest power through the system. And remember, I said that we're going to run the blue first, which is the inside cuts. So we're going to move that up. And we're actually going to disable our the output for the black outside line and just run the inside first. Excuse me, I got you something to drink. Yeah, Alex ain't got nothing on me in Cokes. He's lucky it's not a Corona. Okay, and let's frame it up. Okay, I have to do something first. Almost forgot. So obviously, whenever you're setting everything up, you need to have both output on so that you can get a good frame of everything, and then go back in. All right, now then. So that's a little bit too thick, too fat, like me, too fat. I'm going to squeeze it down just a touch. Um, I'll let you see what I'm doing here. I'm going to take my ugly mug and that off of there and just let you work, see my screen. Okay, so I'm just going to adjust my thickness here. You can get away with doing this a little bit. It's not going to hurt. Just frame that out. All right, I'm going to have to squeeze it down a little bit more. I've already squeezed this way. I don't want to go anymore, so we're going to bring it smaller and hit the P key, bring that in there. Bring it. Now, the one drawback about doing this yourself, as far as running the mill, is that you're not going to have, or I guess you could, but most of the time you're not going to have fully uniform pieces. Like you would get a square or whatever from Rio Grande, which by the way you can do. You can buy 3x3 squares and kind of work from there, but you're still going to wind up needing to recycle. And so you either pay someone to recycle or you do it yourself. And that's kind of up to you. I'm going to stretch this out just a little bit. You do want to be careful, by the way, of getting too close to the edge of your piece, uh, especially if you have milled yourself, because the edge is going to be uh, rough. You're going to have micro fractures all the way around that edge. Okay. All right. So if you get your artwork or something too close to these edges, as I said, they're going, when you press it, you're going to have little micro fractures across it. And we're going to go ahead and run these, and I'm going to leave this running, and we're going to talk a little bit while that is cutting, and that way where you can get an actual idea of the time frame that it takes to do this. All right, so I've disabled my outside line. I want to start working with the inside line first. We're going to go ahead and start. Now, you might start hearing the fan kick on and stuff on my laser source. I'll just have to see how bad this mic gets noisy. Hopefully, everything will work fine. I'm nervous. I want to make sure this works right the first time. Just double check again. Measure twice, cut once. That's good. And I guess I could do a quick pass. Uh, okay, I messed up. I know what I did. Okay. That's perfect. So, you're gonna have to pardon me. I gotta reach through. And yeah, I'm on and grown like an old man, but considering the fact that February the 6th, I broke my back and I'm able to stand up and do this now, I can't complain too much. Okay. All right. Run continuously and start. Now, if you didn't notice, what I did first was I didn't have any kind of fan or exhaust on the system. I know you guys are going to be hollering, you need your exhaust hooked up. You're absolutely correct. I really do. Um, but this is a temporary spot for this. And I'm also going to be experimenting with some shielding gas. And the purpose for shielding gas, for those that don't know, is that silver and a lot of the other metals oxidizes really fast. It's actually oxidizing as that laser is running through cutting. And I believe, or I am thinking, that if I used shielding gas, which creates a barrier to keep the oxygen out of the cut, then it will actually cut faster. So I am going to be getting some shielding gas Monday and setting up a way of keeping that layer of shielding gas over the system and see what kind of cut it does. And you just noticed my JPT laser source came on, the fan came on. It's cutting really well. By the way, the other thing about these glasses, folks, and it was something else I was going to mention, if you get the right ones, and I've really got to do some research on these, I got to find them again. But they have another coating, if you will, on them that uh, lowers the UV radiation coming from the cutting process itself. That actually white light that you physically see, it shields part of that radiation also, making it much easier to look at your work and actually see what's going on instead of just seeing that glare that comes off of there. But where I was going with the thing, you seen that black smoke coming up off this cut? That black smoke actually interferes with the laser beam. Okay, so it's another reason why you need, an exhaust or something when you're working with this stuff. And obviously, you need an exhaust because you've got heavy metals that are being blasted out of there. But when I'm doing the engraving or something like that, I actually have a. I know Alex is probably going to throw something at me, but I have a vacuum cleaner that I have hose hooked up the other side, pulls it out from the other side. But the vacuum cleaner is way too loud to do what I'm doing right now, talking to you folks while running this. All right, so let's talk about the milling and the silversmithing part of this equation, okay? As you work this silver, so pull my ingot, if you will, I pour it and I pull it out of the mold. And at that point in time, it is soft, or what is considered soft. Okay, it's about as soft as the metal's going to get. I run it through that mill and start squeezing it down. It gets work hardened. You're only able to run, depending how hard you're pressing it down, you're only able to run it about 3 to 4 times, maybe 5 times. And yeah, that's already, so I'm just about, by the way, I'm running 13 runs on this laser source, and almost all of my inside squares or inside pieces have been cut out. The reality is I can see the line blasting all the way through, but I'm not going to get in a hurry. I'm going to let it do its job, okay? The less that I have to manipulate to knock these pieces out, the better. Mr. Pascal, man, you sent me one hell of a laser system. I love it. This thing is a beast. You got to think I came from with using a 30-watt Rakis, and Mr. Pascal. We worked together, and he got me a good price on a 50-watt JPT upgrade. Sent it over to me. Took me about I don't know, maybe at the most an hour to put it in. I got to do a little bit more work on the frame so that I can actually physically mount the laser source into it. But sitting here, it's doing what it needs to be doing. So you can watch the laser. And you'll notice whenever it gets to certain points, brightens up. That's telling me that it hasn't quite cut all the way through yet. So I'm going to let it keep working, get through those. Ah, there's one that dropped. Okay, we're good. All right, so we're going to stop that and we'll close that. And then we'll go back over to our cuts and layers, disable my inside and enable the outside cut. Go back over to my laser, start, run continuously. By the way, that was, what's that count? I believe that was like 18, maybe 20. So you can see by how separating that out. Yeah, overall it might take a little bit longer. I don't, but I really don't think so. But what I can tell you is that it's a lot less stressful on the metal, and you don't want to get this stuff hot. Okay, you want to, as much as possible, run cold, uh, and I'll explain to that to you here in a second. Okay, so the reason why, and what I was getting at, is as you run this through the mill, it work hardens. Okay, so you need to play smart with that, and you want to work it. You in the mill, you're going to stretch it out to somewhere where you're wanting the length at, but you're also going to need to widen it, so that everything fits. But in your last part of your passes, you want to pass it through enough to work harden it. In other words, your final piece you want to be work hardened. That way to where when it's time to cut it out, it's going to be at its hardest point and less bendable, less malleable. And so it is closer to being ready for the end client. And I may actually slow this down. I got that set at 100, but it don't seem like it. All right, let's go ahead and stop this, close it, go back to my cuts, and I'm going to set it at a speed of 100. I'm actually going to bring it down to 50. I want that. Oh, that's why. Once again. Okay, there we go. We're going to, actually, I'll bring it to 80. Uh, my wobble is set at zero point 0.5 and at step and a 0.20 size. Okay, and you can sure tell the difference when you have that wobble turned off. So that's what happened. I had disabled the wobble on another piece that I was testing because it had some small parts that I was trying to keep from messing up and messed it up anyway. So we had to reset that and start back over. You know, this is what I actually like about lasers, doing this kind of stuff. Anka had asked me one time before what got me into doing laser work, what I enjoyed about it, and it's this: the experimentation. Um, I love discovering new ideas or new concepts, or trying to tweak someone else's concept and see what comes out of it. Now I know this is a long video, folks, but you got to realize we're going from start to finish, and I'm doing this way because I see all of these guys that will speed the process up, and then you're sitting there scratching your head. Well, how long did it take? Now you can fast forward, and I'll say that I'll do an intro and say this part of it too. But you can fast forward through it. But this actually gives you an idea of how long it takes to do one of these. And so, yeah, I'm much more pleased with that. My first one I did, and I will post that video too. That thin area that I was telling you about was just too thin, and the heat softened. Um, one of the things you can also do too is you just saw me reach over and just barely touch that and bring that head down just a touch. What that does is, you're cutting into a fairly thick piece of metal, and so you can bring it down and bring your focal distance down just a touch so that it goes ahead and cuts a little easier. So, initial investment without counting my laser system, um, my smelter, the milling machine, and the clamp. Tool wise, that was two, three, about $350. Okay, I bought 3 ounces of silver, which is right at $100. Actually, I think it's a little bit more than that, $120. Um, and then my boric acid, which you use whenever you're smelting, um, like for example, recycling. It's going to have some trash in it. So you pour you just a pinch when you're working with this small of a quantity. You don't put a lot in. I mean, you literally just a small pinch, throw it in there, and that helps clean your metal up and get the oxidization and everything out of that metal. So just a pinch of boric acid in there with it. Some things that you can do too is I have a couple here somewhere. Um, be on the lookout for them silver quarters. Silver quarters are 90% silver. What is sterling silver? It is, I believe, um, like 95% silver and 5% copper. So, you know, you buy pure 999 silver, you run a copper quarter, a silver quarter in there, and finish the rest of your weight out with the 999, and all of a sudden you have sterling silver. So, it works. Have you noticed how much faster the inside lines cut, even though they had about the same surface area? This outside line takes much longer, and I don't know why. I don't understand all of that exactly. I guess maybe it has more. It takes longer to get back to the start. I don't know. It's interesting. Stop this real fast. So let's go ahead and hit it again and see what the difference is. A huge difference. You can immediately tell the difference in the way that beam is working into the metal. Run continuously, and let's go ahead and let it do its work. I apologize, folks. Again, I told you from the beginning, this is experimentation for me. There's not a whole lot of people out here doing this, or at least not showing it. I guess partly because they don't want you knowing how to do it. Uh, and the other factor is there's just not a lot of people out here doing it. I mean, you know, a 3 by 3, a 3 inch by 3 inch piece of silver like this costs $100, and you're cutting a little name out of it. If you don't have that smelter and the rolling mill to recycle that, that's the majority of your money is going to be your scrap. So there's not a lot of people out there doing this. So I'm kind of watching, okay, starting to, so we're at 4 passes so far. And at some of the corners, I'm starting to actually see a blast through in the laser, like a partial penetration. I would say probably silver, gold, and copper are three of the metals that are pretty hard to work with. Although I have tried to cut brass, and I'm not having a lot of luck with it either. But I was working with a pretty thick piece of brass too. All right, so we are at 8 passes, and I'm beginning to see a fairly consistent pass through on the beam itself. Now, that doesn't mean that it's a clean cut. What it means is that, remember, this is a pulse. So there's a bunch of little bitty dots that are pulsing through there. And you got to change that pulse up a little bit to finish your cut. Or at least that's my theory. I may be wrong on that, but that's my theory. But I am definitely seeing where it has passed through. And I estimate that we are somewhere right in the area of, let's look at what my recording time is. We are at about 1 hour and 13 minutes, and we probably worked about 30 minutes getting set up, and just about another 30 to 40 minutes in the cutting time. Uh, I have talked to jewelers who do this with a jewel saw, and they have told me that it takes somewhere around 3 hours um, to do this, depending on the size of the letters, number of letters, the difficulty of the font itself. It could take, some of them have actually said that it takes 2 to 3 days, depending on what they're working with. Whereas on a laser, you kind of have a generalized time. Um, it can take a little bit longer, but not exponentially like you would with a handsaw. Now, if I was going to be doing this exclusively, and I wanted to be able to work with much thicker pieces, then I would definitely go with the 100 watt, or possibly even trying to find a small fiber laser cutting system itself instead of a this type of marking engraver. So if you watch your beam, it will tell you a lot about what it's doing. You see right there where the beam is, that light has dropped down, and in places it actually disappears. That tells you, okay, I've blown through. But don't get in a hurry. If you stop this job too fast and you pick it up, once you've picked it up off that bed, you're done. And if you find that there's still a hard area in there, then you're rather going to go ahead and just cut out. All right, so let's stop the laser. I don't want it cutting my, marking up my piece. Once again, you're going to be careful about your scrap. That's money, quite a bit of money. And that's hot. Ouch, that's hot. Put the camera over here. Folks, don't make fun of my workspace. I won't let you in my house again. All right. My wife's going to like that. That's pretty. Much, much better. Much better. Let's see if I can get this to focus. Got it backwards. Now, it's corroded. You know, it has to be pickled. By the way, if you don't know what a pickle is, no, it's not the pickles you eat on your hamburger. But pickling is where you take either a Pacific silver pickle, pickling compound, acids, or citric acid. You heat it up in a little crock pot, and you drop this in there, and it will take all of the scale and stuff off of here. And then just take a little buffing pad on a little hand tool and buff everything out. This really looks nice. My wife's going to like this. And as I said, you know, I'm putting quite a bit of pressure here, okay? I mean, I'm not going to get crazy with it. If you get crazy with it, you're going to break it, okay? There's nothing for that. So what I will need to do next is to go in with a little Dremel tool and a little emery, uh, uh, one of the little round emery tools, and work my edges, kind of clean these edges off and get them nice and clean. And it will be cleaned up and ready to give my wife. A little backstory about that, by the way, folks. I have made it a habit of every time that I invest into something uh, new, if you will, for my laser, to make her the first piece. The first piece that comes out of it is for my wife. And I got a good woman, folks. She lets me go out there and make these kind of investments. And if she hadn't done that, you know, I really probably wouldn't have met you folks. I want to thank Alex and Miranda, along with Matt, and obviously Mr. Pascal, for helping me get into this much more. So I appreciate you folks joining me today, and I know it's a long deal. Hopefully you'll go all the way through it. But again, thank you very much. And you have a great day.